Hi everyone, I welcome you to the 2019-2020 Assam Student Orientation and to present the National School of Applied Sciences. My name is Samtuma Samo. I'm doing engineering at the University Sidi Muhammad Ben Abdallah National School of Applied Sciences or FAIS. So let's get started. Uh, what is Ensa? So Ensa is a school of engineering. It trains engineers under the French system. And what I mean by French system is that the medium of instruction at school is French, and the classification of courses, also the evaluation of students' performance is based on a French standard. So throughout the Kingdom of Morocco, we've got 12 cities that have got the National School of Applied Sciences, and these cities are shown on the map. Yeah, so we've got Agadir, Marrakesh, Bereshit, Kurijba, Ojedida, Fez, Kenitra, Tetuan, Tangier, Osima, and near my screen there, or behind my screen there, is Ujda. So we've got 4 cities where we have Zambian students doing ENSA, and these cities are as follows. We've got Agadir, we have students in Fez, we have students in Tetuan, and we've got Zambian students also in Osima. So now let's get to talk about the ENSA system. So the ENSA system, ENSA trains engineers in a period of 5 years, and successful students are awarded with a diploma data, which is a state engineer's degree, and it is equivalent to a master's level 9 in the English standard. And the 5 years are divided into 10 semesters, meaning each academic year has got 2 semesters. And these 10 semesters are further subdivided into class preparatory or preparatory class and engineering cycle. So the first 4 semesters are classified as preparatory class, and the last 6 are classified as the engineering cycle. So now let's talk about the preparatory class. So the preparatory class, this is the first thing that you do when you start ENSA, and what is involved in the preparatory class. So in this class, you're going to be doing general engineering. You'll be doing the same stuff, like there's no specialization at this stage. So it's general engineering, and it is made up of 24 modules, meaning in the 2 years, you're going to do 24 modules. Each academic year has got 12, and each semester has got 6 modules. So now let's get to talk about the modules that are in this preparatory class. So like the first semester, you're going to do stuff like analysis 1, algebra 1, take physics 1, which is divided into electrostatics and magnetostatics. You're going to do mécanique du poids, which is particle mechanics, and you're going to do informatique, which is divided into architecture des ordinateurs and algorithms. So now you might be wondering, what is analysis 1, what is algebra 1? So I start analysis 1. Well, analysis 1, basically this is mathematical analysis. It's different from the mathematics we know back home or we've done in high school. You're going to be analyzing theorems now, different theorems, mathematical theorems. So it's mathematical analysis in English. And in this analysis 1, you're going to analyze suites, or you're going to study suites. Suites, these are sequences. We've done arithmetic and geometric sequence in high school, so you're going to study them in details, different properties and different theorems that govern suites, the limits of suites, etc. And you're going to study general limits, and also you're going to study the continuity of function, which I've denoted as CF here, which is continuity of function. When does a function continue? When does a function discontinue, etc. And you're going to study also derivability of function, which I've denoted as DF. So this is like basic derivation that we've done in high school, and you're going to do how to derive different functions in different theorems of derivations. And away from that, you're going to do also algebra 1. So in algebra 1, basically here, you're going to start with logic reasoning, which is mathematical reasoning. How do you reason when given a mathematical problem? So logical reasoning, different logical reasonings, and you're going to do sets, you're going to do different structures of arithmetics, you're going to do vector analysis, which is a sparse vector array, groups, and other algebraic structures. So it's an interesting module. It's not much different from what we've done back in high school. It's an interesting module. This makes up algebra 1. Then yeah, in physics 1, as I said earlier, that is divided into two elements. So in the element for electrostatics, in this element, you're going to study static charges. These are charges that are immobile or charges which are not moving. You're going to study their attraction, laws of attraction, like charges repel and like charges attract, the electric field they generate, and different laws that govern the static charges. And you're going to study these static charges in different systems, in different systems that you learn. It's an interesting module, and it has got very good or rather nice applications. It's interesting stuff. And still in physics 1, the other element, magnetostatics. So in magnetostatics, basically here you're going to study magnetic fields. Like in 1883, Michael Faraday said that when an electric current throws through a conductor, a magnetic field is generated around that conductor. And these are the magnetic fields that you're going to be studying, and their nature, their projection, since magnetic fields are vector quantities. So you're going to do vector analysis to determine the final direction of a given magnetic field and its nature. So it's very interesting. It's applied mathematics. You'll be doing it a lot of integration, from simple integration, double integration to triple integration, depending on the nature of the system you're studying. So it's very interesting, and that's got very good applications. One application which I can give is that is now in the specialization sector, like magnetic levitation. It forms the basis for magnetic levitation. Magnetic levitation is a aerial system transport that uses two sets of magnet, one set of magnet to repel the train off the track, and the other set to push the train forward. So it's a technology that has given birth to speed train or bullet trains. I'm sure most of you have seen it. I've seen on TV or anywhere on the internet about the bullet trains, especially in China. And the closest example I can give here in Morocco is the Morocco TGV. So the Morocco TGV, using the French state-of-the-art technology, it runs on an electrified standard draw system gauge that relatively benefits from magnetic levitation, giving it a top speed of 320 kilometers per hour, making it the fastest train on the African continent. Now that's purely the beauty of magnetostatics brought to reality. And moving on to the next module, mechanics du poids, which is particle mechanics. Well, it's another interesting module. Mechanics du poids is divided into three parts, which is kinematic du poids, which is particle kinematics, and dynamic du poids, which is particle dynamics and collisions. So in kinematic du poids, you're going to study the movement of particles in space. What I mean by space is 3D. So analyzing particle movements in 3 dimensions. And so you're going to calculate the acceleration of particles, the velocity of particles, the position of the particle at a given time, without considering the force that is causing those effects. So that is cinematic du poids or particle kinematics. And you're going to study also different reference systems, that is now coordinate systems, different coordinate systems like the Cartesian coordinates that we're all familiar with, the X, Y, Z. You're going to learn about the spheric, the cylindric, and polar coordinate systems. They're very interesting. And you are going to move on to dynamic du poids, which is particle dynamics. In particle dynamics, you're going to study the movement of particles, but in this time around, you take into account the mass of the particle and the forces that are causing the effects, like the movement, the acceleration, the velocity. So you'll be balancing up forces, and you're going to study in details the Newton's three laws of motions. In the first, second, and third law of motions, you're going to study them in details and apply them in particle dynamics. It's very interesting. And they're going to conclude the module by studying collisions. Collisions, these are what happens when two particles collide. So you've been analyzing their properties before and after collision. So you are going to analyze the momentum of the particle before and after collision. That will give rise to elastic and inelastic, elastic or rather elastic and non-elastic collisions. And it's very interesting, and that will conclude the module for mechanics du poids. It's a very big module and very interesting for engineers and to learn for engineering students in short. And you're going to move on to informatic. So, well, informatic is divided into two parts, as I said again earlier. There's architecture designator. So in this part, in this element of architecture designator, you're going to study logics, like logic gates that we've learned in high school. So you're going to study in details the logic gates, and you're going to do logic combinations to come up with integrated circuit like the one shown here, the Intel, this one, the Intel chip. And basically what's under this chip is different logic combinations. And you start from a simple logic gate. You're going to do logic combinations to come up with desired computer components like additioners, subtractors, decoders, encoders, and recorders, and also multiplexers. You're going to understand them when you start doing it. They're very interesting stuff. And from logic combination, you're going to do circuit combination now to come up with different circuit combinations that that will be given the output, your desired output. For example, a simple arithmetic logic unit, which is the basic function of a calculator. This is a chip that can add, can divide, multiply, or subtract numbers. So it's a simple arithmetic logic unit. It all starts from the logic combination and circuit combination to come up with it. And they're going to do also binary language. So meaning computer stores information in binary in base 2 in short. So you're going to do conversion from base decimal, which is base 10, to base 2, hexadecimal, which is base 16, to base 2, and all those stuff. It's very interesting, and it's a very interesting module. It has got a practical part and a theory part. The practical part, you'll be using a software to simulate different logic combinations, and at the end of the day, you're going to do a project for a simple arithmetic logic unit. So you're going to design an arithmetic logic unit that will be able to divide, subtract, and multiply two numbers. That's like a simple calculator in short. And it's very interesting. And the other part of informatic is algorithms. In algorithms, basically, these ones it will give you, it's an introduction to programmation. And in this module, you'll be writing a series of instructions on how to execute a given task on a computer. For example, here, to calculate the x to power n, these are the instructions that you follow. These are the instructions that you follow, and you'll be taught how to write these instructions, the conditions, and everything. So it, as I said, it's a base for further programming languages. It's an interesting module. So moving on to second semester. So in the first semester, as I said, I didn't put tech. Yeah, I showed you tech earlier in the earlier slide. So tech is basically the French language. You'll be taught on how it's the communication language. It's like communication skills in French. So that's basically that's what you'll be doing. It can be integrated with other elements like sports. For other answers, you'll be doing sports, and also there's a French part, and also the in other answers like phase, you find they'll give you enterprise, which is like how to manage a business and the like, and the French part remains as well for communication. And in second semester, you're going to be doing analysis 2. So analysis continues. Analysis 2, this is further mathematical analysis. And in this one, you continue doing it basically integration. You do indefinite integrals and differential equation. It's a very interesting module. And algebra 2, you're going to do polynomials, matrices, and further sparse factorial. And it's also very interesting. It's mathematics. And physics 2, you're going to do electrokinetics, which is electrokinematics in English. And in electrokinematics, you'll be studying the movement of electrons in a closed circuit, how current moves in a electric circuit, and the different theorems that govern the movement of current in a closed circuit. And you're going to do you're going to start it from simple to complex RIOC circuits. You'll be analyzing different circuits. It's very interesting. And optic, you're going to study light. Basically, it's light, the propagation of light in different media. And the main application that you're going to do is in optic fiber. Like, optic fiber is used for its modern communication. You transmit signal at the speed of light. So you're going to analyze how do you come up with an optic fiber, how do you maintain total internal reflection in an optic fiber, and how do you introduce the information to the optic fiber, what should be the bandwidth, or rather the distance between bits of information in the optic fiber so that the information is not lost. It's very interesting. It's an interesting module. Then informatic 2. Well, in informatic 2, here you'll be using, it's basically informatic tools. You're going to learn about computers, engineering softwares, different engineering software. You'll be introduced to different engineering softwares like LabVIEW, MATLAB, and Simulink. So these softwares might vary depending on the Ensa you are at or the town you are going to be studying Ensa from. But there's the MATLAB and Simulink, these are basic fundamentals. But another Ensas, you won't find MATLAB, you'll find other engineering softwares. So like LabVIEW, this is Laboratory Visual Instrumentation Engineering Workbench. It's a very interesting engineering software that allows you to design and simulate dynamic systems that you cannot realize in the lab, like systems that you cannot make in the lab. So you're going to be designing them virtually on the computer and design and analyze their functionalities. And from there, you can come up with an ideal model that you can implement in real life. So it's very practical. We'll be doing a lot of interesting, you'll be dealing with a lot of interesting systems in this module. And MATLAB is also a typical engineering tool. And here you'll be doing with, basically you'll be introduced on how to write algorithms to solve mathematical problems, like how to solve a quadratic equation, how to write a code for a quadratic equation, a polynomial, etc. Matrices also is a very interesting software. It's Matrix Laboratory. This is just an abbreviated form, Matrix Laboratory. Then you also do Simulink. Simulink is inside MATLAB. It's a component of MATLAB. Well, in Simulink, you'll be designing dynamic systems like electrical circuits, RIOC circuits. Now, instead of making them on a circuit board, you analyze them in Simulink, and you analyze their performance. And from there, you get the observations and everything that you need. And also dynamic systems like mechanical systems, mass dampers, and the like. Then, so it's very interesting. It's a very big module from Audio Informatique. These are engineering tools, the informatic tools. And you're going to do general chemie general. Like, this is general chemistry. General chemistry, basically like we did in high school, you start studying matter from an atomic state, which is atomistic. You're going to do crystallography, which is you'll be growing different crystals. And you're going to finish with organic chemistry in details, of course. And It has got a practical part where you'll be analyzing different crystals. Under crystallization, you design different crystals and then you analyze their properties. And also for organic compounds, you'll be designing organic compounds on a software. And then you analyze their properties and different projections and everything. It's very interesting. And tech continues. In this case now, in second semester, you have got English and French. So on the English part is basic English. You'll be learning how to communicate in English, and French, how to communicate in French. Then coming on to the third semester, uh, this is now the second year of preparatory class, where you have got analyst comes again, analyst 3. The analyst 3 is very interesting. And you're going to do in this part, you're going to do topology, and you're going to do multiple integrals. Basically, topology and multiple integrals is a very interesting part here, further mathematical analysis. And Algebra 3 also continues. In this part, you're going to do further, you're going to study matrices now. Maybe you started with matrices in 2 dimensions, 3 dimensions. Now you're going to study matrices maybe in n dimensions, and their properties is very interesting. And other algebraic structures. And also Physics 3, you're going to learn fluid mechanics, fluid statics, and fluid mechanics. Basically, this is now the movement of, you study theorems that govern the movement of fluids and the like. Is a base for hydraulics. Those who are going to specialize in hydraulics, this is the base. You're going to study interesting theories that that govern the movement of fluids. And thermodynamics basically be studying heat, the behavior of heat, and you study in details the 3 laws of thermodynamics, first, second, third, and it's a very interesting module. You study systems like refrigerators and heat systems like a heat pump and the like. Is very interesting. And Informatic 2 is programmation C. Basically, there you cannot graduate as an engineer who doesn't know how to program. So, in programmation is embedded in the courses. So there's programmation C. You'll be taught how to do different programmation and how you'll be programming your systems in future when you start to specialize. And programmation C is a very interesting language. And Mechanic du solid. This is solid mechanics. Unlike particle mechanics, now you're going to study big objects now, like the mechanics of big objects. It's very interesting. It's a very big module. It's just like mechanics to power, but it's bigger than mechanics to power, of course. It's solid mechanics. It's very interesting. And it's physics. Those who like physics, this is the module. And tech continues. You've got English 2, basic communication in English, and you have French, communication in French. Then coming to the last semester of the preparatory class, now you have Analyse 4. So at Ensa, Analyse goes from 1 to 4. So this is the last analysis that you do. So in Analyse 4, it's a very interesting module. It's a very big module as well. It has got about 5 chapters. You're going to do Fourier series, Fourier transforms, Laplace transforms. You're going to do analysis complex and the different theorems that govern analysis complex. It's very interesting. And Algebra 4, in this case, you're going to study, it's divided into, it has got an element which is statistics and probability. So you're going to do Algebra 4 and statistic and probability as one module. So in Algebra 4, you're going to study ring theorems. Ring theorems in English, these are les anneaux in French. Then they are very interesting. You're going to study different theories or theorems that govern ring theories. That is, ring theories. I don't know how you can put it in a basic language, but it's very interesting mathematics. And statistic and probability. This is like basic statistics that we've done in high school, but in details and probability starts from what we know to going into details and different theorems that you learn. It's very interesting. Physics 4. Physics 4 has got electronic analogic. This is analog electronics. Analog electronics, you're going to study these sinusoidal electrical signals, continuous signals in short, like electronic analogic is very interesting. And they're going to do electronic numeric, which is digital electronics, zeros and ones. It's very interesting. And informatic 3. In informatic 3, you're going to do data structures in C. So now, since in S3 you learned about data structure programmation C, in this module now you're going to learn about the different data structures that are in C, how you manage the memory in a given algorithm, in short, like different algorithms that you'll be using, or different structures that you'll be using to write a given algorithm, looking at the optimization of the algorithm and the efficiency and time, in short. You're going to learn about different structures like linked chains, trees, and etc. You learn them. It's a very interesting programming. And operating systems. Well, in operating systems, since now an operating system will now form is an operating system basically forms a link between the hardware and the software of your computer. So now the main the main operating system that you're going to look at here, or you're going to study in detail, is Linux, which is Linux Ubuntu, and it's an interesting operating system. So you're going to do mainly the command lines, how you operate it, the command lines, how the different structures in which it manages its memory dynamically, of course, and etc. And it's a very big model. So then you're going to do durable development and environmental education. So in this one, it is basically aimed at sustainable projects, eco-friendly projects, how to come up with eco-friendly systems, and etc. and the like. It's also interesting. In tech tech 3 here, you're going to study for Ensa phase, you're going to study English and Spanish. For other answers, it might vary as well, as I said earlier. So in at phase, you study English and Spanish, communication in Spanish and communication in English. So now, up to this stage, you've done the preparatory class. Now, in the third year, which is starting from the 5th semester, you'll be doing now the engineering cycle. So engineering cycle, basically here now there's specialization. So you're going to specialize for 3 years. And for 3 years, you're going to do 48 courses, or rather 48 modules, meaning each academic year has got 16 modules, and each semester has got 8 modules. So things change a bit here. And you're going to be doing a specialization. You're divided. You no longer do the general stuff now. Depending on your specialty, you'll be doing your own stuff, in short. Then I'm now going to talk about the specialization that each city offers. Different cities have got different specialization, and it is advised that you do your specialization from the you do your class preparator from the town where your specialization is, as to reduce the complexity of transferring and everything, getting asking for transfers and the like. So it's advised that you do your preparatory class from the Ensa, which has got your desired specialty at the end of the day. So like for Ensa phase, we've got software engineering, we've got telecoms and networking, we've got industrial engineering, we've got mechanic and automated systems, which is like mechatronics, and you've got system embarque, which is embedded systems. That is for Ensa the phase. Then we have got Ensa Agadir. So in Agadir, we've got interesting specializations as well. We've got software engineering, we've got industrial engineering, we've got mechanical engineering, we've got civil engineering, electrical engineering, and agroalimentaire is also engineering. And in Ujda, we've got software engineering, we've got telecoms and networking, we've got industrial, which has got an option of logistic and transportation or transport, and we've got electrical engineering, which has got a specialty in the last year of microelectronics, and we've got electronic engineering and industrial software. Then we have got civil engineering as well. Then we have Kenitra. Kenitra, we've got electrical engineering, we've got telecom and networking, we've got software engineering, industrial engineering, and mechatronics. Then in Ojadida, we've got telecom, we've got software engineering and new technologies, we've got industrial engineering, we've got energy and electrical engineering, and we've got also communication systems engineering, software and communication systems. Then Marrakesh. Marrakesh, we've got software engineering, telecoms and networking, electrical engineering, industrial and logistic engineering. Then Tangier, we've got telecoms and communication systems. We've got industrial. We've got software engineering. We've got also electronics and automations, automated systems, in short. And we've got industrial and logistics and eco energy and industrial and environmental industrial engineering. So these are interesting specialties, but found in different cities. Then now coming to how do you validate a module in at Ensa? Like I'll talk about the preparatory class and the engineering cycle. So to validate a module in the preparatory class, you have to get at least a 10, a general average of 10 in the module. What I mean by general average is that the average for the practical, and the average for the theory together must be above 10, at least 10 or above, then you'd have validated the module. And if a module has got two elements, the average of those two elements must be above 10, and not each element has to be at least 7 or above, not below 7. If it's below 7, you have to redo the element, so 7 or better. And the general average at the end of the day should be 10 or better. And then you'd have validated the module. Then engineering cycle, the general average should be above 12. So here things change a bit. You're now validating at 12. So 12 or better. Anything less than 12 is non-valid. And you have to go for attrapage. Attrapage is like redemption exam. You go write again the exam. You're given a second chance. And at Ensa, there's no threshold for that redemption exam. So long you wrote the exam, even if you got 0, you can still go write the attrapage. Unlike other schools where there's a threshold for you to write a attrapage. And how do you now validate a year? So validating a year in the preparatory class, you need an average. Behind my screen there is you have to get the average of 10. So 10, adding all your elements, all your 6 elements, all your 12 elements in the year, the average should be above 10, and you have to pass at least 9 modules. So 9 modules must be above 10, and the remaining 3 shouldn't be less than 7. Then you validated the year. Then in the engineering cycle, to validate the year, you need a general average of 12. So adding all your 16 elements in the year and dividing by 16, the average should be at least 12 or better. Then you've validated the year. Then now my personal experience at Ensa. Well, coming to Ensa, well, I loved engineering from the start. Yeah, so that's what helped me to survive at Ensa. In short, like I can, to be honest, like the first semester was quite challenging. You get to learn a lot of things within a short period of time, and your French is not well organized. Like you're going in class, you're not understanding most of the stuff what the prof is saying, and reading the technical information that you're being taught at school. It was quite challenging, and time management. Like for Ensa, I'm at Ensa phase. Ensa phase, we learn from 8 to 18:30. So like the whole day you're at school, coming back, time management was an issue. But what is important is to adapt. Like adapting was the most important factor, and determination at the end of the day. So it was quite challenging, I can say, but with time, it kept on getting better, and it's still getting better. And I enjoy what I do. I enjoy engineering, and that's what is pushing me. So I'd advise you to like what you're doing. Like that's the thing that is going to help you go through all the challenges that you'll be facing. Otherwise, if you don't like what you're doing, uh, things might get rough. Like it can get crazy. But if you really like what you're doing, you enjoy it despite the challenges that you face. And my experience might not be your experience. We've got different abilities, and yeah, we're all A+ students. It's manageable, and anyone can do it with determination, of course. And yeah, that's my brief experience at Ensa, and I'm still doing it, and I enjoy what I'm doing. And so, coming to the end of this presentation, I want to say thank you for your attention, and may God bless you, and may God bless the great Zasam community. I thank you.